Anti-aircraft warfare or counter-air defense is defined by NATO as all measures designed to nullify or reduce the effectiveness of hostile air action. They include ground and air-based weapon systems, associated sensor systems, command and control arrangements and passive measures, e.g. barrage balloons. It may be used to protect naval, ground, and air forces in any location. However, for most countries the main effort has tended to be homeland defense. NATO refers to airborne air defense as counter-air and naval air defense as anti-aircraft warfare. Missile defense is an extension of air defense, as are initiatives to adapt air defense to the task of intercepting any projectile in flight. In some countries, such as Britain and Germany during the Second World War, the Soviet Union, NATO, and the United States, ground-based air defense and air defense aircraft have been under integrated command and control. However, while overall air defense may be for homeland defense including military facilities, forces in the field, wherever they are, invariably deploy their own air defense capability if there is an air threat. A surface-based air defense capability can also be deployed offensively to deny the use of airspace to an opponent. Until the 1950s, guns firing ballistic munitions ranging from 20 mm to 150 mm were the standard weapons. Guided missiles then became dominant, except at the very shortest ranges, as with close-in weapon systems, which typically use rotary autocannons or, in very modern systems, surface-to-air adaptations of short-range air-to-air missiles. Terminology. The term air defense was probably first used by Britain when Air Defence of Great Britain, ADGB, was created as a Royal Air Force Command in 1925. However, arrangements in the UK were also called anti-aircraft, abbreviated as AA, a term that remained in general use into the 1950s. After the First World War it was sometimes prefixed by light or heavy, LA or HA, to classify a type of gun or unit. Nicknames for anti-aircraft guns include AA, AAA, or AAA, an abbreviation of anti-aircraft artillery, ACAC, from the spelling alphabet used by the British for voice transmission of AA, and Archie, a World War I British term probably coined by Amyas Borden, and believed to derive via the Royal Flying Corps, from the music hall comedian George Robey's line Archibald, certainly not. NATO defines anti-aircraft warfare, AAW, as measures taken to defend a maritime force against attacks by airborne weapons launched from aircraft, ships, submarines, and land-based sites. In some armies the term all-arms air defense, AAAD, is used for air defense by non-specialist troops. Other terms from the late 20th century include GBAD, ground-based AD, with related terms SHARAD, short-range AD, and MANPADS, man-portable AD systems, typically shoulder-launched missiles. Anti-aircraft missiles are variously called surface-to-air missile, abbreviated and pronounced SAM, and surface-to-air guided weapon, SAGW. Non-English terms for air defense include the German Flak, Flygabwehrkanone, aircraft defense cannon, also cited as Flugabwehrkanone, whence English flak, and the Russian term Protivovzdushnaya obrona, Cyrillic, a literal translation of anti-air defense, abbreviated as PVO. In Russian the AA systems are called zenitny, i.e. pointing to zenith, systems, guns, missiles etc. In French, air defense is called DCA, Défense contre les aéronefs, aéronef being the generic term for all kind of airborne device, aeroplane, airship, balloon, missile, rocket, etc. The maximum distance at which a gun or missile can engage an aircraft is an important figure. However, many different definitions are used, but unless the same definition is used, performance of different guns or missiles cannot be compared. For AA guns only the ascending part of the trajectory can be usefully used. One term is ceiling, the maximum ceiling being the height a projectile would reach if fired vertically, not practically useful in itself as few AA guns are able to fire vertically, and maximum fuse duration may be too short, but potentially useful as a standard to compare different weapons. The British adopted effective ceiling, meaning the altitude at which a gun could deliver a series of shells against a moving target. This could be constrained by maximum fuse running time as well as the gun's capability. By the late 1930s, the British definition was that height at which a directly approaching target at 400 miles per hour equals 643.6 km/h can be engaged for 20 seconds before the gun reaches 70 degrees elevation. However, effective ceiling for heavy AA guns was affected by non-ballistic factors. The maximum running time of the fuse, this set the maximum usable time of flight. The capability of fire control instruments to determine target height at long range. The precision of the cyclic rate of fire, the fuse length had to be calculated and set for where the target would be at the time of flight after firing. To do this meant knowing exactly when the round would fire. General description. The essence of air defense is to detect hostile aircraft and destroy them. The critical issue is to hit a target moving in three-dimensional space. An attack must not only match these three coordinates, but must do so at the time the target is at that position. This means that projectiles either have to be guided to hit the target, or aimed at the predicted position of the target at the time the projectile reaches it, taking into account speed and direction of both the target and the projectile. Throughout the 20th century, air defense was one of the fastest evolving areas of military technology, responding to the evolution of aircraft and exploiting various enabling technologies, particularly radar, guided missiles, and computing, initially electromechanical analog computing from the 1930s on, as with equipment described below. Air defense evolution covered the areas of sensors and technical fire control, weapons, and command and control. At the start of the 20th century, these were either very primitive or non-existent. Initially, sensors were optical and acoustic devices developed during World War I and continued into the 1930s, but were quickly superseded by radar, which in turn was supplemented by optronics in the 1980s. Command and control remained primitive until the late 1930s, when Britain created an integrated system for ADGB that linked the ground-based air defense of the Army's AA command, although field-deployed air defense relied on less sophisticated arrangements. NATO later called these arrangements an air defense ground environment, defined as the network of ground radar sites and command and control centers within a specific theater of operations which are used for the tactical control of air defense operations. Rules of engagement are critical to prevent air defenses engaging friendly or neutral aircraft. Their use is assisted but not governed by IFF, identification friend or foe, electronic devices originally introduced during the Second World War. While these rules originate at the highest authority, different rules can apply to different types of air defense covering the same area at the same time. AAAD usually operates under the tightest rules. NATO calls these rules Weapon Control Orders, WCO. They are: weapons free, a weapon control order imposing a status whereby weapons systems may be fired at any target not positively recognized as friendly. Weapons tight, a weapon control order imposing a status whereby weapons systems may be fired only at targets recognized as hostile. Weapons hold, a weapon control order imposing a status whereby weapons systems may only be fired in self-defense or in response to a formal order. Until the 1950s, guns firing ballistic munitions were the standard weapon. Guided missiles then became dominant, except at the very shortest ranges. However, the type of shell or warhead and its fusing end, with missiles the guidance arrangement, were and are varied. Targets are not always easy to destroy. Nonetheless, damaged aircraft may be forced to abort their mission and, even if they manage to return and land in friendly territory, may be out of action for days or permanently. Ignoring small arms and smaller machine guns, ground-based air defense guns have varied in caliber from 20 mm to at least 150 mm. Ground-based air defense is deployed in several ways. Self-defense by ground forces using their organic weapons, AAAD. Accompanying defense, specialist aid defense elements accompanying armored or infantry units. Point defense around a key target, such as a bridge, critical government building or ship. Area air defense, typically belts of air defense to provide a barrier, but sometimes an umbrella covering an area. Areas can vary widely in size. They may extend along a nation's border, e.g. the Cold War MiM-23 Hawk and Nike belts that ran north-south across Germany, across a military formation's maneuver area, or above a city or port. In ground operations, air defense areas may be used offensively by rapid redeployment across current aircraft transit routes. Air defense has included other elements, although after the Second World War most fell into disuse. Tethered barrage balloons to deter and threaten aircraft flying below the height of the balloons, where they are susceptible to damaging collisions with steel tethers. Searchlights to illuminate aircraft at night for both gun layers and optical instrument operators. During World War II, searchlights became radar-controlled. Large smoke screens created by large smoke canisters on the ground to screen targets and prevent accurate weapon aiming by aircraft. Passive air defense is defined by NATO as passive measures taken for the physical defense and protection of personnel, essential installations, and equipment in order to minimize the effectiveness of air and/or missile attack. It remains a vital activity by ground forces and includes camouflage and concealment to avoid detection by reconnaissance and attacking aircraft. Measures such as camouflaging important buildings were common in the Second World War. During the Cold War, the runways and taxiways of some airfields were painted green. Organization. While navies are usually responsible for their own air defense, at least for ships at sea, organizational arrangements for land-based air defense vary between nations and over time. The most extreme case was the Soviet Union, and this model may still be followed in some countries. It was a separate service, on a par with the Army, Navy, or Air Force. In the Soviet Union this was called Voiska PVO, and had both fighter aircraft, separate from the Air Force, and ground-based systems. This was divided into two arms: PVO Strany, the Strategic Air Defense Service responsible for air defense of the homeland, created in 1941 and becoming an independent service in 1954, and PVO SV, Air Defense of the Ground Forces. Subsequently, these became part of the Air Force and Ground Forces respectively. At the other extreme, the United States Army has an air defense artillery branch that provided ground-based air defense for both homeland and the Army in the field. However, it is operationally under the Joint Force Air Component Commander. Many other nations also deploy an air defense branch in the Army. Other nations, such as Japan or Israel, choose to integrate their ground-based air defense systems into their air force. In Britain and some other armies, the single artillery branch has been responsible for both home and overseas ground-based air defense, although there was divided responsibility with the Royal Navy for air defense of the British Isles in World War I. However, during the Second World War the RAF regiment was formed to protect airfields everywhere, and this included light air defenses. In the later decades of the Cold War this included the United States Air Force's operating bases in UK. However, all ground-based air defense was removed from Royal Air Force, RAF, jurisdiction in 2004. The British Army's Anti-Aircraft Command was disbanded in March 1955, but during the 1960s and 1970s the RAF's Fighter Command operated long-range air defense missiles to protect key areas in the UK. During World War II the Royal Marines also provided air defense units. Formerly part of the Mobile Naval Base Defense Organization, they were handled as an integral part of the Army-commanded ground-based air defenses. The basic air defense unit is typically a battery with 2 to 12 guns or missile launchers and fire control elements. These batteries, particularly with guns, usually deploy in a small area, although batteries may be split. This is usual for some missile systems. Scharad missile batteries often deploy across an area with individual launchers several kilometers apart. When MANPADS is operated by specialists, batteries may have several dozen teams deploying separately in small sections. Self-propelled air defense guns may deploy in pairs. Batteries are usually grouped into battalions or equivalent. In the field army, a light gun or Scharad battalion is often assigned to a maneuver division. Heavier guns and long-range missiles may be in air defense brigades and come under corps or higher command. Homeland air defense may have a full military structure. For example, the UK's Anti-Aircraft Command, commanded by a full British Army general, was part of ADGB. At its peak in 1941-42 it comprised 3 AA Corps with 12 AA divisions between them. History. Earliest use. The use of balloons by the U.S. Army during the American Civil War compelled the Confederates to develop methods of combating them. These included the use of artillery, small arms, and saboteurs. They were unsuccessful, but internal politics led the United States Army's Balloon Corps to be disbanded mid-war. The Confederates experimented with balloons as well. The earliest known use of weapons specifically made for the anti-aircraft role occurred during the Franco-Prussian War of 1870. After the disaster at Sedan, Paris was besieged and French troops outside the city started an attempt at communication via balloon. Gustave Krupp mounted a modified 1-pounder, 37 mm, gun, the ballon à boire canon, balloon defense cannon, or Bach, on top of a horse-drawn carriage for the purpose of shooting down these balloons. By the early 20th century, balloon, or airship, guns, for land and naval use were attracting attention. Various types of ammunition were proposed: high explosive, incendiary, bullet chains, rod bullets and shrapnel. The need for some form of tracer or smoke trail was articulated. Fusing options were also examined, both impact and time types. Mountings were generally pedestal type, but could be on field platforms. Trials were underway in most countries in Europe, but only Krupp, Ehrhardt, Vickers Maxim, and Schneider had published any information by 1910. Krupp's designs included adaptations of their 65 mm 9-pounder, a 75 mm 12-pounder, and even a 105 mm gun. Ehrhardt also had a 12-pounder, while Vickers Maxim offered a 3-pounder and Schneider a 47 mm. The French balloon gun appeared in 1910. It was an 11-pounder but mounted on a vehicle, with a total uncrewed weight of 2 tons. However, since balloons were slow-moving, sights were simple. But the challenges of faster-moving aeroplanes were recognized. By 1913 only France and Germany had developed field guns suitable for engaging balloons and aircraft and addressed issues of military organization. Britain's Royal Navy would soon introduce the QF 3-inch and QF 4-inch AA guns, and also had Vickers 1-pounder quick-firing pom-poms that could be used in various mountings. The first U.S. anti-aircraft cannon was a 1-pounder concept designed by Admiral Twining in 1911 to meet the perceived threat of airships, that eventually was used as the basis for the U.S. Navy's first operational anti-aircraft cannon, the 3/23 caliber gun. First World War. On September 30, 1915, troops of the Serbian army observed 3 enemy aircraft approaching Kragujevac. Soldiers shot at them with shotguns and machine guns but failed to prevent them from dropping 45 bombs over the city, hitting military installations, the railway station and many other, mostly civilian, targets in the city. During the bombing raid, Private Radoj Ljudovac fired his cannon at the enemy aircraft and successfully shot one down. It crashed in the city and both pilots died from their injuries. The cannon Ljudovac used was not designed as an anti-aircraft gun. It was a slightly modified Turkish cannon captured during the First Balkan War in 1912. This was the first occasion in military history that a military aircraft was shot down with ground-to-air fire. The British recognized the need for anti-aircraft capability a few weeks before World War I broke out. On July 8, 1914, the New York Times reported that the British government had decided to dot the coasts of the British Isles with a series of towers, each armed with 2 quick-firing guns of special design, while a complete circle of towers was to be built around naval installations and at other especially vulnerable points. By December 1914, the Royal Naval Volunteer Reserve, RNVR, was manning AA guns and searchlights assembled from various sources at some 9 ports. The Royal Garrison Artillery, RGA, was given responsibility for AA defense in the field, using motorized 2-gun sections. The first were formally formed in November 1914. Initially they used QF 1-pounder pom-pom, a 37 mm version of the Maxim gun. All armies soon deployed AA guns, often based on their smaller field pieces, notably the French 75 mm and Russian 76.2 mm, typically simply propped up on some sort of embankment to get the muzzle pointed skyward. The British Army adopted the 13-pounder, quickly producing new mountings suitable for AA use, the 13 PDR QF6 CWT Mk3 was issued in 1915. It remained in service throughout the war, but 18 PDR guns were lined down to take the 13 PDR shell with a larger cartridge, producing the 13 PR QF9 CWT, and these proved much more satisfactory. However, in general, these ad hoc solutions proved largely useless. With little experience in the role, no means of measuring target, range, height, or speed, the difficulty of observing their shell bursts relative to the target gunners proved unable to get their fuse setting correct, and most rounds burst well below their targets. The exception to this rule was the guns protecting spotting balloons, in which case the altitude could be accurately measured from the length of the cable holding the balloon. The first issue was ammunition. Before the war, it was recognized that ammunition needed to explode in the air. Both high explosive, He, and shrapnel were used, mostly the former. Airburst fuses were either igniferous, based on a burning fuse, or mechanical, clockwork. Igniferous fuses were not well suited for anti-aircraft use. The fuse length was determined by time of flight, but the burning rate of the gunpowder was affected by altitude. The British pom-poms had only contact-fused ammunition. Zeppelins, being hydrogen-filled balloons, were targets for incendiary shells, and the British introduced these with airburst fuses, both shrapnel-type forward projection of incendiary pot and base ejection of an incendiary stream. The British also fitted tracers to their shells for use at night. Smoke shells were also available for some AA guns. These bursts were used as targets during training. German air attacks on the British Isles increased in 1915, and the AA efforts were deemed somewhat ineffective, so a Royal Navy gunnery expert, Admiral Sir Percy Scott, was appointed to make improvements, particularly an integrated AA defence for London. The air defences were expanded with more RNVR AA guns, 75mm and 3-inch, the pom-poms being ineffective. The naval 3-inch was also adopted by the Army. The QF 3-inch 20 CWT, 76mm, a new field mounting, was introduced in 1916. Since most attacks were at night, searchlights were soon used, and acoustic methods of detection and locating were developed. By December 1916 there were 183 AA sections defending Britain, most with the 3-inch, 74 with the BEF in France, and 10 in the Middle East. AA gunnery was a difficult business. The problem was of successfully aiming a shell to burst close to its target's future position, with various factors affecting the shell's predicted trajectory. This was called deflection gun laying. Offset angles for range and elevation were set on the gun sight and updated as their target moved. In this method, when the sights were on the target, the barrel was pointed at the target's future position. Range and height of the target determined fuse length. The difficulties increased as aircraft performance improved. The British dealt with range measurement first, when it was realized that range was the key to producing a better fuse setting. This led to the height/range finder, HRF, the first model being the Bar and Stroud UB2, a 2-meter optical coincident rangefinder mounted on a tripod. It measured the distance to the target and the elevation angle, which together gave the height of the aircraft. These were complex instruments, and various other methods were also used. The HRF was soon joined by the height/fuse indicator, HFI. This was marked with elevation angles and height lines overlaid with fuse length curves. Using the height reported by the HRF operator, the necessary fuse length could be read off. However, the problem of deflection settings aim-off required knowing the rate of change in the target's position. Both France and UK introduced tachymetric devices to track targets and produce vertical and horizontal deflection angles. The French Brock system was electrical. The operator entered the target range and had displays at guns. It was used with their 75mm. The British Wilson Dalby gun director used a pair of trackers and mechanical tachymetry. The operator entered the fuse length, and deflection angles were read from the instruments. By the start of World War I, the 77mm had become the standard German weapon, and came mounted on a large traverse that could be easily picked up on a wagon for movement. Krupp 75mm guns were supplied with an optical sighting system that improved their capabilities. The German army also adapted a revolving cannon that came to be known to Allied flyers as the flaming onion from the shells in flight. This gun had 5 barrels that quickly launched a series of 37 mm artillery shells. As aircraft started to be used against ground targets on the battlefield, the AA guns could not be traversed quickly enough at close targets and, being relatively few, were not always in the right place, and were often unpopular with other troops, so changed positions frequently. Soon the forces were adding various machine gun-based weapons mounted on poles. These short-range weapons proved more deadly, and the Red Baron is believed to have been shot down by an anti-aircraft Vickers machine gun. When the war ended, it was clear that the increasing capabilities of aircraft would require better means of acquiring targets and aiming at them. Nevertheless, a pattern had been set: anti-aircraft warfare would employ heavy weapons to attack high-altitude targets and lighter weapons for use when aircraft came to lower altitudes. Interwar years. World War I demonstrated that aircraft could be an important part of the battlefield, but in some nations it was the prospect of strategic air attack that was the main issue, presenting both a threat and an opportunity. The experience of 4 years of air attacks on London by Zeppelins and Gotha GV bombers had particularly influenced the British and was one of, if not the main driver for forming an independent air force. As the capabilities of aircraft and their engines improved, it was clear that their role in future war would be even more critical as their range and weapon load grew. However, in the years immediately after World War I, the prospect of another major war seemed remote, particularly in Europe where the most militarily capable nations were, and little financing was available. 4 years of war had seen the creation of a new and technically demanding branch of military activity. Air defense had made huge advances, albeit from a very low starting point. However, it was new and often lacked influential friends in the competition for a share of limited defense budgets. Demobilization meant that most AA guns were taken out of service, leaving only the most modern. However, there were lessons to be learned. In particular, the British, who had had AA guns in most theaters in action in daylight and used them against night attacks at home. Furthermore, they had also formed an AA experimental section during the war and accumulated a lot of data that was subjected to extensive analysis. As a result, they published, in 1924-5, the 2-volume textbook of anti-aircraft gunnery. It included 5 key recommendations for HA equipment. Shells of improved ballistic shape with HE fillings and mechanical time fuses. Higher rates of fire assisted by automation. Height finding by long base optical instruments. Centralized control of fire on each gun position, directed by tachymetric instruments incorporating the facility to apply corrections of the moment for meteorological and wear factors. More accurate sound location for the direction of searchlights and to provide plots for barrage fire. 2 assumptions underpinned the British approach to HA fire. First, aimed fire was the primary method, and this was enabled by predicting gun data from visually tracking the target and having its height. Second, that the target would maintain a steady course, speed, and height. This HA was to engage targets up to 24,000 feet. Mechanical, as opposed to igniferous, time fuses were required because the speed of powder burning varied with height, so fuse length was not a simple function of time of flight. Automated fire ensured a constant rate of fire that made it easier to predict where each shell should be individually aimed. In 1925 the British adopted a new instrument developed by Vickers. It was a mechanical analog computer predictor AA number 1. Given the target height, its operators tracked the target and the predictor produced bearing, quadrant elevation, and fuse setting. These were passed electrically to the guns where they were displayed on repeater dials to the layers who matched pointers, target data and the gun's actual data, to lay the guns. This system of repeater electrical dials built on the arrangements introduced by British Coast Artillery in the 1880s, and Coast Artillery was the background of many AA officers. Similar systems were adopted in other countries, and for example the later Sperry device, designated M3A3 in the US, was also used by Britain as the predictor AA number 2. Height finders were also increasing in size. In Britain, the World War I bar and Stroud UB2, 7 feet optical base, was replaced by the UB7, 9 feet optical base, and the UB-10, 18 feet optical base, only used on static AA sites. Gortz in Germany and Laval-Lois in France produced 5-meter instruments. However, in most countries the main effort in HA guns until the mid-1930s was improving existing ones, although various new designs were on drawing boards. From the early 1930s 8 countries developed radar. These developments were sufficiently advanced by the late 1930s for development work on sound locating acoustic devices to be generally halted, although equipment was retained. Furthermore, in Britain the Volunteer Observer Corps formed in 1925 provided a network of observation posts to report hostile aircraft flying over Britain. Initially radar was used for airspace surveillance to detect approaching hostile aircraft. However, the German Würzburg radar was capable of providing data suitable for controlling AA guns, and the British AA No. 1 Mk1 Gallon radar was designed to be used on AA gun positions. The Treaty of Versailles prevented Germany having AA weapons, and for example, the Krupp's designers joined Bofors in Sweden. Some World War I guns were retained and some covered AA training started in the late 1920s. Germany introduced the 8.8 cm Flak 18 in 1933, 36, and 37 models followed with various improvements, but ballistic performance was unchanged. In the late 1930s the 10.5 cm Flak 38 appeared, soon followed by the 39. This was designed primarily for static sites but had a mobile mounting, and the unit had two 20V 24 kW generators. In 1938 design started on the 12.8 cm Flak. The USSR introduced a new 76 mm M1931 in the early 1930s and an 85 mm M1938 towards the end of the decade. Britain had successfully tested a new HA gun, 3.6 inch, in 1918. In 1928 3.7 inch became the preferred solution, but it took 6 years to gain funding. Production of the QF 3.7 inch, 94 mm, began in 1937. This gun was used on mobile carriages with the Field Army and transportable guns on fixed mountings for static positions. At the same time the Royal Navy adopted a new 4.5 inch, 114 mm, gun in a twin turret, which the Army adopted in simplified single gun mountings for static positions, mostly around ports where naval ammunition was available. The performance of the new guns was limited by their standard fuse number 199, with a 30-second running time, although a new mechanical time fuse giving 43 seconds was nearing readiness. In 1939 a machine fuse setter was introduced to eliminate manual fuse setting. The US ended World War I with two 3-inch AA guns, and improvements were developed throughout the interwar period. However, in 1924, workstation.
Please subscribe and thanks for watching.